Howdy, let's take a look at this, which is the Lewis dot structures of covalent molecules. Okay, this is a very important video. Trust me, it's super important. Okay, make sure that you watch the whole thing and make sure that you understand it all because it's incredibly important. Okay, now to start off this video, okay, I could read all of this stuff to you, and then in a very few minutes you would all be asleep because you don't want to hear me read things to you. Okay, so here's what I'm going to do. I want you to pause the video and I want you to read 1 through 6. No, seriously, pause it. Pause it and read it. Okay, go. Okay, I'm going to assume that you paused the video and watched it. I hope you did because it's important. Okay, now one thing that I do want to go over is this little blip right here, okay, about some exceptions to the octet rule. Okay, now since you've already read this, you know that the octet rule is the fact that elements need 8 electrons around them in order to be stable. Okay, it's kind of like that whole isoelectronic thing that we talked about so much last unit. Now, we're going to assume that every atom wants 8 electrons. Okay, the differences, in that is that hydrogen only wants 2 electrons. Beryllium only wants 4 electrons. Boron only wants 6 electrons. And sometimes sulfur and phosphorus and a few others can have more than 8 electrons, and that's called an expanded octet. Okay, those, my friends, are the exceptions to the octet rule. So let's go ahead and do some examples. Okay, the first example that we want to do is H2O. And the first thing that we need to do is determine who is our central atom. Now, I know that hydrogen can never, ever, ever, ever be a central atom. It's too tiny to be a central atom. So I know that oxygen is going to be my central. So I'm going to draw oxygen right there in the middle. And that means that H2, meaning I have 2 hydrogens, those are my peripheral atoms. So I'm going to put hydrogen here and hydrogen here as my peripheral atoms. Now I need to know how many atoms I have to work with. So I'm going to add up all my valence electrons. So oxygen brings 6 electrons to the table. Each of my hydrogens bring 1 electron to the table, which means that I have a total of 8 valence electrons that I can play with to draw my Lewis dot structure with. Okay, now because I read all the stuff up above this, I know that the next thing that I need to do is I need to satisfy my central atom. Okay, so I'm going to satisfy oxygen by giving him 1, 2, 3, 4, 5, 6, 7, 8. I know that oxygen now is happy because he has 8 electrons around him. Now, here's the situation. Anytime that you have electrons that are between 2 atoms, you know that those are going to share those electrons, okay? So now oxygen thinks that all of these electrons belong to him, okay? Oxygen thinks that all of these electrons belong to him, so he's happy, okay? Hydrogen, because these electrons are between hydrogen and oxygen, hydrogen thinks that these electrons belong to him. Remember, hydrogen's one of our exceptions. So if hydrogen has 2 electrons, then he's happy. Okay? This hydrogen thinks that these 2 electrons belong to him. So he is happy as well. So now notice that these electrons are actually being shared between oxygen and hydrogen. But either way, that's how a bond is going to form. Okay? Now, did we use up all 8 of our electrons? Yes, we did. Okay? So I have no other electrons that I need to worry about. Now, another way that I can draw this is just like this. I could put oxygen as my central atom, hydrogen as my 2 peripherals, okay? And instead of drawing dots in between these, I can actually make a bond, okay? I can draw a line that makes a bond. Anytime that you have a line in between 2 atoms, that represents 2 electrons, okay? So it's like an electron here and an electron here that's being shared between the 2. Okay, and I need to put all of my electrons here. But it's like, if you draw a line, then it's like sharing 2 electrons. okay? So that's how you're going to see me do things most often. So let's go ahead and take a look at HI. Okay, if I've got HI, okay, I need to determine who's my central atom. Well, hydrogen can never be a central atom, so that means that iodine will be my central atom. So let's determine how many total valence electrons I have. Hydrogen brings 1 valence electron to the party, and iodine brings 7 valence electrons, meaning that once again I have 8 valence electrons to play with. So let's go ahead and satisfy my central. Now, instead of just satisfying my central with electrons this time, I'm going to go ahead and draw a bond, okay? Because I know that something's going to happen with these. So I'm going to draw a bond, which stands for 2 electrons. And then, so I've got 1, 2 for iodine. 1, 2, 3, 4, 5, 6, 7, 8, okay? Iodine is now happy. He has 1, 2, 3, 4, 5, 6, 7, 8. He's happy. He's got all the electrons that he needs. Hydrogen also is happy because he has 2 electrons. And based on the exception to the rule, I know that hydrogen's happy as well. I've used up all my electrons, so I'm good. So now what's up with this Abx formula thing, okay? The A stands for your central atom. How many centrals do you have? I only have 1 central atom, so that's going to represent A. The B is how many peripheral atoms do I have? Well, I have 2 hydrogen atoms, so that's going to represent B2. Lastly, I have unshared pairs of electrons. Okay, that's what X is. X is how many unshared pairs of electrons do you have? Well, this pair of electrons is unshared, and this pair of electrons is unshared. On the central, that's important, okay? It's got to be on the central. So I have 2 unshared pairs of electrons on the central atom, so this is going to be an Ab2X2 structure. Don't worry, we're going to practice a lot more in class, in the video, all kinds of good fun stuff, okay? Now, this one down here, what's my central atom? Iodine is my central atom. I have 1 of them. Hydrogen is my one and only peripheral atom. I have 1 of them. And now my X, how many unshared pairs do I have on the central atom? Well, iodine's my central atom, and I have 1, 2, 3 unshared pairs. So this would be an Abx3 structure. Let's take a look at another one here. Let's do Bi3. Why not? Okay. With Bi3, I need to determine a central. Okay. Since boron is the leading one, and it's not hydrogen. Okay. Since it's the leading one, it's not hydrogen, and it's the one. It's the only one that we have 1 of. That's going to be my central. Okay. Iodine is my peripherals. I've got 3 of them. So iodine and iodine and iodine. Okay, and let's determine how many valence electrons we're bringing to the table. Boron's in group 13, so it's going to bring 3 electrons to the table. Iodine's in group 17, so each one is going to bring 7 electrons to the table. So that means 7 times 3 is 21, so I'm bringing 21 electrons with all of my iodines, giving me a total of 24 valence electrons. So now what do? I need to satisfy my central. Boron is a exception. Boron only wants 6 electrons. So I know that he's going to share with all these. So I'm going to go ahead and make bonds. So I'm giving boron 1, 2, 3, 4, 5, 6 valence electrons. Is boron happy with 6? Yes, he is. So now we can move on. So now let's see what we did. So I have 6 valence electrons that I just used, meaning I've got 18 left. What do I do with the 18 left? I have to satisfy my peripherals, okay? So now I'm going to satisfy all of my peripherals. So they've already got 2. Remember, each bond is 2 shared electrons. So each of these iodines already have 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 electrons. I used them all up. Everybody's happy, and so we are good to go. Now, that means that I have 1 central atom, A, 3 peripheral atoms, B. How many unshared pairs? Oh, well, look at all these unshared pairs. On the central, okay, they've got to be on the central atom. I have no unshared pairs on the central, so therefore, this is just an AB3, because I've got 1 of those, 3 of these, so this is an AB3 structure. Okay, let's look at 2 more, and then that'll be the end of this video. OMG, we're already at 10 minutes. Yes, let's make it quick. Okay, NCl3. We're just going to do this one, and then we're going to be done with this video. NCl3, I've got nitrogen as my central. Okay, I've got 3 chlorines as my peripherals. Boom, boom, and boom. Okay, let's see how many I got. Nitrogen, 5. Group 17 for this, I've got 3 of them, so 21 total, meaning I've got 26 total electrons. Let's satisfy the central. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I've used 8 valence electrons, meaning I've got 18 left. You know what to do now. We're going to satisfy our peripherals. 1, 2, 3, 4, 5, 6. He's already got those 2, so that makes 8. 1, 2, 3, 4, 5, 6. So that was 6, 12, 13, 14, 15, 16, 17, 18. Everybody's happy. So now I've got an A, B3. How many unshared pairs on the central? 1 unshared pair. So that gives me A, B, 3, X. So that's my structure here. All right, we've got a lot more of these to do, which means that I'm going to have to make another video. Oh, yeah. So yeah, boom. Done. In a second, done.